Hello guys, here we go. We're on to this next mechanism now. It's called the addition elimination mechanism, and you have to be able to do this for 4 different types of nucleophile in the first step, the addition step. But every time we start off with one of these, okay? So this is an acyl chloride. Remember that carbon is delta plus, this oxygen is delta minus. Okay, really important, fairly straightforward. So we'll start off with the most basic nucleophile. In this case it's water, so write it OH2, and it's got a lone pair of electrons on it. What's going to happen? Well, this is delta plus and we've got a lone pair of electrons. The nucleophile is going to add to that carbon, and that's going to kick the electrons out onto that oxygen, and we have to draw our intermediate at this step. So here is our intermediate. Because that the double bond is broken, we end up with this lone pair and a negative charge on this oxygen, and down here where we have added the nucleophile we end up with water stuck on here, but because our nucleophile gave up its lone pair over here, we end up with a positive charge on our nucleophile. So what happens from here? This chlorine is our leaving group, so we kick these electrons back in there, the chlorine leaves, and to neutralise this positive charge we also lose one of our hydrogens here. And the final thing we do is just draw our product, which in this case, if our pen is working, here we go, in this case we've made a carboxylic acid and we have eliminated HCl. So that's the first one of these types of mechanisms you have to do, okay?